Let us continue the discussion and let us see what all we can do with DPM. So by default, I've mentioned to you in the previous video that the boundary condition type for discrete phase model conditions is reflect for the walls. Okay. Now, if you want the particles to be trapped, okay, and if you don't want the particles to reflect off, then you can simply change the boundary condition from reflect to trap and click apply and close. Now what you can do is you can simply go back to the graphics and particle tracks. Click on particle tracks. First and foremost is to draw the mesh, close it, and then compute the display. Yeah, and now you can see the difference over here, right? In the previous cases, if you remember, 660 particles were entering and 660 particles were leaving the domain, isn't it? And this was possible because there was a reflection of particles from the walls and they were just moving off. But now you can see a drastic change actually. You can see 660 particles are entering, that is well and good, but the amount of particles that are escaping is mere 118, right? So where are the rest of particles? The rest of the particles are trapped. They are trapped at the wall, okay? And you can see the number of particles which are trapped. Those are 542. Okay, this is almost closer to 80%, I believe, like more than 50% you can say. So these are impacting the wall. The water droplets are impacting the wall, and that is what is happening over here, right? So this is the way how you can change the boundary condition and see how many particles are escaping, how many particles get trapped if we are turning on the trap option for the wall. And by this method we can understand that the water droplets at that velocity will, for this distribution what we have created, will impact the wall surfaces. Clear? This is what is about the boundary conditions of DPM. So I'll just wind up the video over here.